Hello guys, welcome back. So in this today's session we are going to see about the HDLC protocol. So what is the HDLC means? High level data link control, right, protocol. So which is used in the bit oriented mechanism, right? So HDLC is a bit oriented protocol for communication over the point to point or multi point links, right? So point to point means if you have the connecting from the one system to the another system, this is what we called as the point to point link. So what is the meaning of multi-point means? Where one device can be able to communicate with the multiple device. This is what we called as the multi-point, right? So HDLC will be used for either point to point or multi-point connection, right? So now what are the configuration and transfer modes in the HDLC is that there are two types. One is called as the normal response mode, nothing but NRM. Another one is the ABMR, asynchronous balance mode. It means that how the communication will be established from the transmitter to the receiver based on how information is exchanged, how acknowledgement we will be getting. So based on we have the one is normal response mode, another one is the asynchronous balance mode. First we will see that what is the operation of the normal response mode, right? So this is also called as the unbalanced mode. So what is the meaning of this one is, in normal response mode the station configuration is unbalanced. We will see why it is unbalanced. We have one primary station and multiple secondary station. It means that we will be having the one primary station, there may be one secondary station, or we might be having the multiple secondary stations. So it means that if you want to send the information will be sent only by the primary station, but the secondary station, what is the operation that it can able to do is, see that a secondary station can only respond based on the, right, so based on the command sent by the primary station. Like if you observe here flow control mechanism in noisy-less channel, we have discussed the different mechanism, right, like stop and wait ARQ, go back and ARQ, right? So these things what will be happen means, from sender to receiver we are going to send the frame, right? So for sending the frame, after receiving that to the receiver, that receiver is just going to send only acknowledgement. It is not going to send the one more frame back to the sender, right? So this is what the operation of the normal response mode. Now if you observe here, you will understand is that, see that, so this is only we have the one primary station, only the primary station have the capability to send the information, nothing but the command. So based on the command received at the secondary stations, the secondary station can able to only respond, but it cannot able to send any commands, right? So this is in case of the point to point communication. We have said that we have the multi-point also, right? So multi-point means we have one primary station, multiple secondary stations. It may be 2, 3, 4, 5, whatever it may be. Whatever the command information is sending by the primary station will reach by the multiple secondary station. So the what is the duty of the secondary station is that it will only respond based on the command sent by the primary station. So see that we have the two secondary station means we will be getting the two responses, right? So this is the unbalanced mode, right? Now for that what we are going to do is, we are going to learn something called as the asynchronous balance mode operation, right? You see that the configuration is balanced. So how the configuration is balanced means, the link is point to point, right? So something like this, it is having the point to point, and each station can function as the primary and a secondary, right? So it means that where at the same time both the sender, nothing but this may be sender, and the receiver can transfer or receive the frames at a time. So it means that, for example, if you take WhatsApp or something, whatever it may be, so from one person to the another person, if you are sending the information something called as the hi, so he is also responding, right? So he will not send the acknowledgement of the hi, right? So what he will tell us is that hello something. It means that he is sending the new information. Inside of the new information we will be having the acknowledgement also. It means that we will be having the information plus acknowledgement of the previous received data. That is what we called as the piggybacking, as we discussed in the previous lectures. So if data is carried along with the acknowledgement, then it is called as the piggybacking. This is something we have the both way operation, unlike in the, like what we discussed in the noisy-less channels. Right, now see that this can able to send the command, the same time this can able to response according to the previous information received to the particular mission. See, both command and response we have, that is what we called as the piggybacking concept, right? So thing is that we can use the HDLC either in balance or unbalanced mode, depends upon our requirement, right? Now we will see that what are the three types of the frames. This is the most important question you will be getting in the most of the time in exam point of view. What are the three types of the frame in HDLC protocol, right? So HDLC is what? Bit oriented protocol. There are three frames. One is called as the I frame, another one is called as the S frame, another one is called as the U frame. I is nothing but the information frame. This is for supervisory frame. This is unnumbered frame. So if you want to understand this concept, how I frame, S frame, U frame look like, means what is the functionality of the each and every frame, means first you should have idea about the framing concept in the data link layer, right? So which we have explained in the previous classes. If you don't watch the previous class, please try to watch the previous class also, so that after understanding the framing concept, then understanding of these three types of these three types of frames are the very easy, right? Now see that in framing concept what we have done is that whatever the data which is received from the network layer, that is what we called as the payload, right? Nothing but the information or data, right? So for that in data link layer, nothing but the layer 2, we are adding the header portion as well as the trailer portion. In header portion what we are going to do, we are going to add the something called as the source MAC address of the device as well as the destination MAC address of the device. In trailer part we are going to perform something called as the flow control operation as well as the error control operation. Now as we discussed in the framing class, right? So if you want to exchange the one frame from one system to the another system, or you consider from one node to the another node, it has to pass through the link, communication link. Now see that the moment it is called as the frame, which will be understand only by the nodes in between the communication, but this link will not understand the framing concept. Now what we have to do is, we need to convert this frame in terms of the bits. The moment if it is receiving at the receiver, again these bits in the link should be converted in terms of the frames, so that you will be getting the frame as well as the frame at the output side. Now how to find out what is the length of the frame, means it may be different framings, right? We will be having in real time. So how to find out where the frame will be start, where frame will be end, means for identification purpose we are extra thing, that is what we called as the flag bit value, right? So we are adding the flag sequence. So if you remember, the flag bit sequence is something 0, 6, 1, 0. This is the 8-bit value. So what is the use of this flag sequences, means whenever you detect the first flag value, you treat that some data is coming, you need to make it as the frame. So at what time you need to make it as the continuously frame? The moment if you receive the one more flag value, something 0, so right? So 0, 6, 1, 0, then flag is going to be closed. It means that until then whatever you received, that is you need to make as the one frame, right? So if you understand this concept, then here we will be having the some control information, right? So what is the use of control information, means it is carrying along with your data, it is going to carrying acknowledgement, that is what we called as the control, right? For flow or error control operation, right? So for this one here we have some extra mechanism, that's it, right? So in I frame what is there, in supervisory frame what is there, in unnumbered frame what is there, that is we are going to discuss. Now see that, as I told that payload is nothing but the some information, right, which is received from the network layer, is nothing but the layer 3, right? Now header portion what we are going to do, we are going to add the address, right? What is the source MAC address as well as the destination MAC address, right? As I told that, again we will be having the something called as the piggybacking concept, right? So along with the data we are going to carry the acknowledgement also, right? So for flow control, error control operation, for that here extra information will be added, will be the control information. It means that for header field, actually in flag concept we have only address, so here extra thing will be added in the control portion, right, in asynchronous balance mode operation. Now see that, now here what we discussed, trailer, right? So for what error, something like flow control, error control operation, means here that what we called as the frame check sequence, right? So this is used to perform the some kind of error detection operation. Now see that, as we know that what is the use of the flag, to identification is the what is the starting flag as well as the ending the flag. So this is what the iframe will be consist of. See that what iframe will be consist of means whichever the data coming from the network layer, that will be consist of the iframe value. Now if we consider the supervisory frame, it won't carry any data, like whatever the data coming from the network layer, it won't carry. It just will carry only the control information. Now see that here we have no information field in the S frame. Now here we will be having the something the unnumbered frame or U frame. The extra information is the management information. So what is the meaning of the management information means, right? So for example here, see that U frame are reserved for the system management. So what is the system management? Something like you can consider the establishment of the link as well as the termination, right? Now see that iframe are used to transport the user data from the network layer and also add the control information related to the user data, right? So whatever the user data we will be having, so along with that we are adding something called as the control information. So that is what we called as the piggybacking operation, right? So remember that S frame is used to only, right, to transport the control information only. It won't carry any kind of the user information or management, system management information, right? So this framing information we need to write in the exam point of view, right? Now if you observe here, the starting flag, ending flag, address, control, frame check sequence is the same for the all the frames. But where the difference? In iframe you will be having the extra something called as the user information which is coming from the network layer. In case of this frame, right, so what we will be having the extra thing, there is the system management, nothing but the link establishment as well as the termination. These three things you need to mention in the exam point of view, right? Now see that we are going to learn about this some more things on the what control frame will be consisting of the exactly, right? So as we discussed in the previous itself, flag field means for identification sequence we are going to add the something 0, 6 ones 0s, 8-bit value, again 0, 6 ones 0, right? So to identify the what is the start of the flag value as well as the end of the flag value. So address field means something source device as well as the destination device. As we discussed that what is the purpose of the control field is that for flow and error control operation. It may be 1 byte as well as the 2 byte long. So depends upon our requirement, we are going for the 1 or 2 byte information, right? Now see that what is the information field consist of the data which is received from the network layer is nothing but the information field, right? So what is the use of frame check sequence? To perform the error detection field operation. Now we will see that for each, right, either it may be I frame, S frame, U frame, you will be having the control information, right? So now we are going to see this specifically what is the operation of the control information. So in our case we can use the either 1 or 2 byte long. In this case what we are doing means we are considering only 1 byte, right, as represented here. 1 byte means how many bit representation it is? 8-bit representation. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8-bit representation. It means that we are considering the 1 byte representation. Now how to identify? For it is I frame 8-bit only, S frame, U frame also identify 8-bit only. Now how to identify which one is related to the I frame and which one is related to the S frame and which one is related to the U frame means, see that if starting of the bit is 0, then it is called as the I frame representation. Out of 8-bit, if MSB bit value is said to be 0, then it is the meaning of the I frame is activated, right? Suppose if the last 2-bit value is something 1 0, it means that S frame is activated. If last 2-bit value is 1 1 means it means that we will be having the U frame or unnumbered frame is particular thing. Now out of this 1 bit is for identification. Next we have something called as the 7 more bit, right? So this was 0 1 2 3 4. This 5th bit we called as the pole final bit, right? So this pole and final bit most of the time we are not going to use, right? So this will be activated or set when it is set to be 1 only, right? If it is not set to the 1, there is no useful of the pole and, right, final bit. Suppose see that here we have the something pole, here we will be having the something called as the final. So what is the meaning of pole means? When the frame is sent by the primary station to the secondary station, it means that when the address field contains the address of the receiver, this address field contains the address of the secondary device or receiver, right? So that is what we called as the polling. It means we are sending the data. Now see that final means what is the meaning of this one is when the frame is sent by the secondary to the primary, it means that something like you can consider final acknowledgement or something you can consider, right? So secondary to the primary, it means that when the address field contains the address of the sender. So this means if address field of this one is contains the address of the primary, then it is called as the final. So remember that if it is set to be 1 only, this function will be activated, otherwise there is no significance of the poll as well as the final. Poll means something you are going to perform the selecting operation. Now what is the meaning of two more representation? One is called as the this representation ns, another one is called as the nr. So what is the meaning of this one is sequence number of frames sent. Suppose as we discussed in the previous lectures, like stop and wait ARQ, go back any ARQ, something, right? We will be having the frame numbers, right? Something 1, 2, 3, 4, 5, 6, 7 from the sender side to the receiver side, right? Now what is the meaning of this one is sequence number of the frames sent. Suppose for example, see if window is something like this, so this is the sequence number of the frames sent, right? Now what is the meaning of here 3 more bit value nr means sequence number of the next frame expected. So next frame is what is expected, fourth one, right, to send from the sender to receiver, something like this you need to understand, right? So this is what sequence number of the frames sent, sequence number of the next frame expected. We will see that what is the meaning of code bit value here. This you have to remember, guys, right? For I frame, what is this one? For S frame, what is this one? For U frame, what is this one? For control information, it is mandatory, right? So we'll see that code for supervisory or unnumbered frame, right? Now see that if you consider the S frame value, how to identify? If these 2-bit value 10 means this is what we called as the S frame. Now what is the meaning of these two code mean? Two possibilities, right? Either it may be 00, 01, 1011. So 2-bit information 0001 1011, right? So 00 means it is something receive ready representation. So it is something reject, receive not ready, select rejective, right? So in examination point of view, you don't need to write all these things also. Just you try to remember this one and you explain this one. So what is the frame, right? So like these three you need to write. So after writing these three, then we need to explain the each and every field. Once it is completed, what is the I frame control information, S frame control information, as well as the U frame control information you need to mention, right? So if you want to have the more information about this one, this code means you just read this one, right? So when this operation will be performed, when this will be performed, or when this will be performed. Now see that where in case of the U frame we have this, right? This is also code, this is also code, right? This is 2-bit information, this is the 3-bit information, right? So see that if 00 this one as well as the something 001, now this command we are going to use set normal response mode. So we have these kind of the commands we are using here, right? This no need to remember, right? So I hope you understand. Thank you very much, guys. Thank you.